Hello students, today we are going to discuss about a very interesting topic, and that is parallax error. So let us understand what do we mean by parallax. So what is parallax? So parallax is the apparent displacement of an object because of a change in the observer's point of view. So while traveling in train, you must have noticed that the objects which are closer to the train, they appear to be moving faster than those which are far away from the train. And this effect is precisely known as parallax. Now you may be thinking that what is this parallax error? Well, this is the type of error which the students usually make while taking measurements of something. For example, if I have this sheet of paper and whose length is this and we have its breadth as this, and now somebody asks me that how will you measure the breadth of this paper? So how can we measure it? Precisely, we can make use of a measuring scale. Quite simple. Okay. So now you know that the measuring scale, like this one, it has got some thickness, as you can see here. So now let's place this scale along the breadth of the page such that one edge of the page, it coincides with the 0 mark on the scale. And here it is. So now we are going to note down the scale reading at the other end of the page, which is right here. So at this point of time, our line of sight is directly above the measuring scale. And we have a direct line of sight, and so we can see that the page, it ends at 21 centimeters. Now what do you think? Will I get the same measurement if I look at this measuring scale by slightly tilting to different sides? Okay, let's check it out. So I'm going to first move to this side, and now I'm going to note down the reading. So as you can see here, now the reading, it comes out to be 21.2 centimeters. So initially we had 21 centimeters, and while looking at from this angle, I get a reading of 21.2 centimeters. Now let us try what happens to the reading if I see from this angle. So while viewing this measuring scale from this angle, my reading, it is approximately 20.8 centimeters. So we had 21 centimeters with the direct line of sight. From this angle, we had 21.2 centimeters. And now from this angle, I am having 20.8 centimeters. So what do you think? Does your orientation of sight really matters? Does it cause some error while measuring the reading? Yes, it is very evident from this activity itself that the orientation of our sight, it does matter while measuring the reading using a measuring instrument such as this measuring scale. And so from this activity, we can conclude that if we view the objects at an oblique angle with respect to this measuring scale, then it makes the object appear to be at a different position on the scale. And what do we call such an error? Yes, so such an error is known as parallax error, which occurs when the measurement of the object is taken by positioning your eye at different angles with respect to the measuring scale. So now, do you know why does this parallax error actually occur? So this parallax error, it occurs due to the gap between the top surface of the scale on which we have the markings and the surface on which the scale is placed. Or you can say that it is due to this thickness of the measuring scale. And what can we do to minimize the parallax error? Very simple. The scale edge, it is made as thin as possible in order to minimize this parallax error. Now we can relate this concept with a daily life example. So I'm sure you all must have seen this instrument inside your vehicle, be it your father's car or your brother's scooter or bike. And what is the name of this instrument? Yes, so it is known as a speedometer. And what does a speedometer do? So as is evident from the name itself, a speedometer, it measures the speed of your vehicle. So now my question to you is, how will the reading vary if you view a car's speedometer from the driver's seat and then from a passenger seat next to the driver? Well, you'll get an accurate reading if you view the speedometer from the driver's seat. And why is it so? Yes, that's because if you look at the speedometer from the driver's seat, then you have a direct line of sight. And so you get a more accurate reading. And now if you view the speedometer from the passenger seat, which is right next to the driver's seat, then you tend to overestimate the reading. And that's because, why is it so? Yes, that's because the parallax between the speedometer pointer and the speedometer scale. Now this is the case that usually happens in countries like India, because in India, the driver's seat is on the right hand side, and that is, we follow the right hand side driving. But what if we talk about other countries such as United States? Then there, the driver's seat, it is on the left hand side. And if you're sitting there as a passenger on the right hand side of the driver's seat, then you will tend to overestimate or underestimate the reading. Well, yes, in such a case of left hand side driving, we tend to underestimate the reading because of the parallax between the speedometer pointer and the speedometer scale. So let's do a quick recap. So we have the right hand side driving system, which is in India, where you tend to overestimate the reading while sitting on the seat which is next to the driver. And in the countries like United States, where we follow left hand driving system, you tend to underestimate the reading of the speedometer while you're sitting next to the driver's seat. So this is about a parallax error, and we can avoid it by looking directly above the measuring scale while taking the measurement of any physical quantity. So with this, I end this module, and we will meet again with another interesting topic.